Hello, welcome to all. In this video, we are going to see about UART communication. UART is the most popular serial communication protocol. In this protocol, we are communicating with two devices with two pins, means transmit and receive. In both devices, if we consider these both devices, every device has transmit pin and receive pin, as well as other devices also having transmit and receive pin. UART is a universal asynchronous receiver and transmitter, means it is asynchronous communication, means there is no common clock in between those. So we are communicating by serially. Through the transmit pin, you have to give from LSB to the MSB whatever data we have to transmit. Means if example we have to take character A, it is have some value which is means a binary value. If you want to transmit that binary value to the another device, we have to transmit logic from LSB to the MSB. But before transmitting, we have to initialize the communication. For initialization of a communication, we have to clear the transmit pin as 0. Means in UART communication, the start bit is 0. After the start bit, we have to give the 8 consecutive bits, a bit by bit, and then finally you have to give the stop bit. Means this is the transmit pin. This transmit pin is directly connected to receive pin. Whatever changes you have to make this transmission pin is directly reflected on receive pin. It gives me like that whenever if I make this transmission pin as logic 0, which directly reflect on receive pin. So if I want to transmit an 8-bit data, I have to give logic 0 first as a start bit, then LSB to least significant bit to most significant bit, bit by bit, then I have to give stop bit, which means that it is a frame, my 8 bits of data with start bit and stop bit. If we can also give the parity bit if we require, but actually we can ignore that one. Why? Because regularly we use only start bit and our 8 bits data and stop bit, means this 10 bits of data is considered as one frame. So this is my data. If I want to transmit these data to another device by this device, I have to make this transmission pin. First of all, I have to make this pin as transmit pin. If we consider LPC2124 microcontroller, let's open the datasheet. In datasheet, if you try to find UART 0, LPC2124 has two UART, means UART 0 and UART 1 peripherals. And if you go through that, in UART 0, pin 0.1 means port 0, pin 1 is RxD0, which is receiver input, and pin 0 on port 0 is transmission pin. We have to make pin 0.0 and 0.1 as transmission and receive pin for one microcontroller. If you take another microcontroller, in those pins, every pin has some functions. We have to know by the data sheet which pin have that function, means transmission or receive. Then we have to make that pins as transmission or receive. How can we make the transmission pin and receive pin? For making transmit pin or receive pin, in LPC2124 we have registers like pin select 0 and pin select 1. Every pin has some functionalities like 3, 4, etc. If we want to switch one function to another function, we have to make those pin has different functions by giving in pin select 0, it is like 32-bit register. Every 2 bits is working for one pin. Like if I want to change the function of pin 0.0, I have to make changes in pin select 0 of 0 and 1th bit. Means If you consider, let us example, this is the pin select 0. It is having 32 bits. I have to make changes on these 2 bits, 0 and 1. 1 means if I make changes to function 1 or function 2 like that, the functions are given to the pin number 0. Like that, there are 32-bit register. For pin select 0, 16 pins are available. For those 16 pins, we can change functions by pin select 0 by making defaultly they are 0 0 means the function 1. If we make it as 0 1 function 2, like that it is like function 0, function 1, function 2, function 3. Like that 4 functions are there, we can modify them. We have to give baud rate and how much data we are passing through the transmission pin. As we see that here we are trying to give 8 bits of data, but we can give sometimes 4 bit of data, where we can give 4 bits of data whenever sometimes I have to give very less amount of data. At that time I can give 4 bit or like 10 bit also. So for this purpose we can give how much data length it would be, and also we have to give divider value for VPB divider, means VLSI peripheral block divider, which gives a frequency to our peripherals like UART, ADC, DAC. Computer clock is there, na? System clock. We cannot give that system clock directly to the peripherals. So we are dividing that system clock to our required value. VPB divider have some divider value. We can set the divider value by setting values to DLL and DLM. These are the registers. This DLL is 8-bit register and DLM is 8-bit register. If you take U0 LSR, U0 LCR is a 8-bit register. So we are taking an 8-bit. In U0 LCR, there are 8 bits. The last 2 LSBs means this 0 and 1. These bits are for setting the data length, means which is 8-bit or 10-bit, which mode we are transferring. So we have to give which mode we are working for. Then there is one more bit, that is MSB, called DLAB, means divisor latch access bit. Divisor latch access bit is for accessing those divider registers, means DLL and DLM. DLL is divisor latch least significant bit, divisor latch most significant bit. After getting a divider value, we have to load the divider value into DLL and DLM, but we cannot directly access this DLL and DLM by setting 1 in this DLAB bit. At that time only we can access this DLL and DLM. So this DLAB bit is for accessing this DLL and DLM. This is U0 LCR. After that, we have to consider about U0 LSR. If you see that this U0 LCR, U0 LSR, U0 RBR, U0 THR, these are special function register used in UART 0. U0 LCR means line control register. U0 LSR means UART 0 line status register. This U0 RBR means UART 0 receive buffer register. UART 0 transmission hold register. This U0 LSR is also 8-bit register. It has 8-bit vacancy. In those 8 bits, we are considered about only the 0th pin and the most significant bit only. In 0th pin, this is called as data ready, and the 6th one means this is 1, 2, 3, 4, 5, 6 transmission empty, and we also consider this MSB also for checking the status of there is a buffer for our transmission data. Whenever we want to transmit some data, directly we can give that value that is stored in a temporary buffer, then it will transmit to the receiver device. If you look carefully, whenever we give a 8 bit of data, that will stored in a temporary buffer. While transferring a bit by bit from LSB to MSB, transmitting the last bit, whenever the last bit also transmitted, the whole buffer will become empty. At that time, this TEMT bit becoming 1 means up to that its default value is 0. The transmission whole buffer is there now, the buffer will empty, means our transmission is completed. Then this data ready bit, this is for check whether my data successfully received or not. There is a buffer, temporary buffer for transmission hold register, like that receiver buffer also there, that is our U0 RBR. While receiving, first of all, my receiving started with initial position, initial bit with 0. Whenever 0 occurred on my receiver pin, my receiving was started. Then bit by bit, from whatever I am transmitting from this transmission pin, this is received. This received pin are stored in receive buffer. Receive buffer 8 bits of register. Whenever it full, this data register becoming 1. So by this U0 LSR, we can know whether my transmission completed or not, and also we can know that data is already received or not. After receiving, my data is ready, so at that time only it will becoming 1. As you see this is U0 RBR, means my receive buffer register, and this is U0 THR, means transmit hold register. Whenever I have to transmit some data, I have to give that value directly to this U0 THR. As we are doing with peripheral method, directly we can give that value to this U0 THR. After giving that value to the U0 THR, it start transmitting from this transmit pin to this receive pin. Whenever my whole data from this LSB to MSB bit was transmitted, then my time TEMT becoming 1. At that time I will know my transmission was successfully completed. Then whatever data I am transmitting, means I am changing logics of this transmission pin directly reflecting on receiver pin, those are stored in this RBR register. Whenever this RBR register is filled with that 8 bits data, this data register will becoming 1. So my transmission was successfully completed, but I cannot access this U0 RBR and U0 THR. For this I have to use my U0 LCR, which is my line control register. For accessing these DLL and DLM, for divider set we have used bit as 1, and I have to clear that bit, means I have to make this DLab bit as 0. At that time only I can access this U0 RBR and U0 THR, which makes me directly I can access this U0 RBR, and I can take that value from RBR and I can give that value for THR. So if you see this, that crystal oscillator directly gives some like 12 megahertz to 15 megahertz, that is given to PLL. It will multiply and give my system clock, but I cannot directly give to that to my peripheral, so I am dividing with a divider value. This divider value, I can give this divider value to this VPB divider by setting this DLL and DLM. Okay, how to calculate my divider value? For calculating divider value, we have to take PCLK by PCLK means our peripheral clock. Peripheral clock by 16 into baud rate. What is baud rate? Baud rate is like that number of bits per a second. Means normally or regularly we have used 9600 baud rate for LPC 2124. Means in 1 second 9600 bits were transmitting or transferring through a pin. So if I want to transmit more than that, like double of the 9600, 19200 or 4800, that is our requirement. According to our requirement, we can modify the divider value by giving PCLK by 16 into baud rate, means it's giving me my divider value. By calculating the divider value, whatever value you have getted, in those value you have 8 bits of LS byte data and MS byte data, means least significant byte that has to load into this DLL and remaining MS byte into DLL. If you want to transmit a data, first of all we have to make those pins as transmission receive pin. For that there is a pin called pin select 0, means which is a register. Pin select 0. I have to make last two pins, pin 0.0 and pin 0.1 of LPC 2124. I am talking about LPC 2124. Two functions of two, means transmission pin and receive pin. Means transmission and receive pins are the second functions of those pins. So I have to make that pins as transmission and receive pin. So I have to give 0x05, which means 101, means 0101 for making this functions 2, means transmit and receive pin. I have made transmission and receive pins. Then I have to give U0 LCR. In U0 LCR there is DLAB bit and the least significant bits. The two bits are there for which length it is. So I have to give 0x83, means U0 LCR is 8-bit data. If I give 1 here and remaining these 1 and 1 for 8-bit of data, these 4 pins are the, and these 4 pins are 8. So we have to give 0x83. Then only we can give modifications to our divider value. After calculating our divider value, I have calculated divider value already, which is getting 97 for my baud rate of 9600 baud rate and PCLK of 15 MHz. I am directly giving U0 DLL equal to 97, which means I have loaded with divider value. We can give MSB value to this U0 DLM, or directly we can give 0 also. We have set the divider value, so we have to make the DLAB bit as 0, means we have to clear that. Then we are making again LCR to 0x03, which means we are clearing that DLAB bit, it is becoming 0x03. So with this we have set divider value and transmit and receive pins are completed. Then we have to give whatever value we have to transmit directly to U0 THR equal to something character you want. Then wait for the transmission complete. U0 LSR right shift with 6 and end with 1, which means it give me the 6th bit of the U0 LSR. You have to wait for it becoming 1, means up to transmission empty it will 0 only. Whenever the transmission hold register will becoming empty, at the time only it will becoming 1. So up to 0 it will wait. Whenever transmission completed, then only it will go to the downer side. Then if you want to receive the data from any other LPC 2124 or any microcontroller, first of all you have to wait for U0 LSR. In U0 LSR the 6th bit is for transmission empty and U0 LSR 0th bit is for data ready. You have to check whether my data is ready or not. Up to 0 means up to my receive buffer not fill, the value is only 0. So if I give while here, it will wait. Whenever receiving completed, then only it will becoming 1. It come down. After that we can directly return that RBR value, means whatever value we are transmitted and The transmitted value is stored in this receive buffer register. We are waiting for that status register whether data is ready or not. Whenever the data is ready, we are directly returning. So this is the algorithm for transmitted data and receive any data. Thank you for all.